Just gonna do sound test. Okay. That's good. Fire up the live notification. Published. All right. Okay, then. What are we doing today? So last time we kind of started this stuff. Today is the 21st. We're kind of in progress with this, so I'm just going to copy these items down and kind of show what we're doing. So we did finish the hash table implementation for spell check. And now we need to do one for glyph cache. There might be one or two more, but let's try and tackle this one for today. There's actually 2 hash tables inside of this thing. So it'll be kind of fun to solve those problems independently. Eventually I want to get over to the buffer manager. So that's going to be the next thing. Yeah, so last time we kind of fixed this thing where spell check was using a hash table, and we fixed it to implement our own hash table, which supports separate chaining. And I went through a lot of fun debugging with that thing. You can see on the last VOD. But let me kind of show you what I did off stream. Let's save this real quick. So in off stream, what we did, or what I did, let me explain what we did actually on stream first. So on stream, we created this this edit set thing, which gives us this hint size thing is something I did off stream, but this sets up the initial table. And then we created this function on stream, which goes through and hashes the data, the incoming edit, and places it appropriately in that table. All that stuff, all this stuff we did on stream, so nothing has changed here. Yes, this is all the same. This is all the same as well, so this is just adding the next or this is just creating the candidate list out of the valid pieces. The thing that did slightly change is this thing here. So I realized that since the performance of this algorithm is so very sensitive to making sure that we don't have a very large load on the hash table. And again, the load is the number of chains, like the maximum chain that you have in any given bucket. So that's like what we're defining as the load here. So keeping that really low is key to getting performance out of this algorithm. So the one thing you can do is you can hint the edit word size. And the way we do that is we basically calculate how many elements are going to be in each set. So for a given word, when you invoke edits1, which creates the set of words that are the permutations and the transposes and deletes and stuff of a specific, like, quote unquote misspelled word, that is 54n plus 25. So like that's how big that set is. So this is a really good helper for figuring that out. And then the edits to distance is a much, much larger set because it's essentially like, it's essentially all of those individual words, and then you take all those words and recompute edit one on every single one of them. So it's kind of like you're multiplying all of them together by however many entries there are. So this set ends up becoming huge, which is why we want to hint it like very large. Or why we get edit to estimate based on the word size +1, because we actually end up adding a character on the insert step. So this is kind of like a heuristic, and then we just multiply it by however many words are inside of our set to begin with. And because there might be duplicates, we use the count here. instead of just reusing what this result was. This will give us, in theory, a slightly smaller set. So that's essentially how that particular piece of it fell out, and you end up getting like really good performance out of that. Much better actually than I was getting out of the old Stood set version of it. The only downside is that, and we can see this, actually I need to build this with, let's build this with arena tracking enabled so we can kind of see like what's going down. So we can open up license here. Oh, I guess that, did I not spell it right? Is it because I didn't do this? That's weird. I would have expected that to work. License not a regular file. Okay, I guess it just won't open it. Anyway, we'll open it ourselves. I'll have to debug that later. That's weird. So if we turn on our spell checker and we pull up our arena sizes here, let's pay attention to peak size. So peak size gets kind of big sometimes, especially with like larger words. Like this one will probably go, yeah, like 8 megabytes, but it does go back down. Like it expands and then it goes down very quickly. So it's not going to use like, it's not going to keep that 8 megabytes around permanently. And you can kind of see that like based on this size here, this doesn't really change like no matter how many times we invoke it, right? So we're just using a Scratch Arena for all that stuff. So I might go back and do something to where we can optimize the memory usage there, but its performance is really, really good, and it gives us the results that we want. So I think for now we're going to call that a success is in terms of like transferring over to just arenas, but we can rethink the solution there later. Anyway, that is not what we're tackling today. Oh, let me call out the rest of the things I did. So I also went ahead and removed all of like these standard containers from this API. So originally this was taking in a stood vector by pointer and just filling it in, which is fine. But now it's all arena allocated, right? Like this misspelled is just something that's handed by the caller, and then we take in an arena and return the suggestions array, which is allocated in this arena here. So it's a much simpler API because of that. Yeah, that's pretty much all this came down to. It was pretty straightforward, which is nice. But now we want to go on to, and that's why I marked it completed. But now we want to go on to like the glyph cache, and this is like something that's a little bit more complicated because there's actually two separate things we're going to be managing here. One is there is a unordered map for code points to their specific glyph information. And then there's a map which takes the size of the font and has the cached version of that font. So actually that entire Unicode code point stuff for the individual Unicode glyphs are all cached inside there. We can take a look at glyph cache. My goodness. Okay, so if I look at, oh, here it is. Okay. So here's an unordered map for the Unicode, or for the code points. So each code point maps to a specific glyph. And actually this needs to be reworked a little bit if I eventually want to do things like graphing clusters. So this will actually have to be a collection of code points instead of one code point. But the fact that it's one code point right now is actually very convenient, and we're going to exploit that for our map. Anyway, So it maps to this glyph information, which is like, what is this stuff? So it's a char info, and the char info is defined up here. This is like actually the advance and all that fun stuff that we get back from the free type library. This tells you like where to actually lay out the glyphs, or like how to perform layout as you're rendering the glyphs yourself. And then it has the face that was the original like target font, because it's possible that this Unicode glyph is coming from a font that's not the primary font. Like it's coming from a completely different font that you loaded because it happened to have that glyph. So anyway, we have this and a couple of other little pieces of information that record like various properties. So the first thing that we're going to do is we're going to try and get rid of this whole thing. And essentially store that. We're going to store this new map inside of this thing here. So whenever these cached fonts go away, their glyph, like this, whatever's allocating this thing, which is probably going to be its own arena actually, is going to also go away. So we need to make sure that we maintain that as we're getting rid of this stuff, because this thing actually does get cleared. So if I look at when this is, so we in place here and then we clear it there. Okay, yeah. So that will have to be done. Well, let's get started. Let's make sure we got it. Okay, cool. We're on a clean baseline, so let's go ahead and get cracking. So I think the first thing we want to do is, where is this thing used? Got the info. So I think we just want to give this a next pointer so we can start separately chaining them. I think we're just going to keep going with separate chaining. That seems to be treating us pretty well so far. Yeah, I think we're probably going to end up doing that. The other thing I want to do is I want to basically measure how far we need to take this, because our first pass of implementing this hash table is not going to come with rehashing. We can do rehashing very easily, but I want to see how far I could take it without rehashing. Like what's like a appropriate number of elements I can allocate up front for the buckets that will be good enough to render like most Unicode documents. So essentially my main target is this thing here, tests Unicode stress. So this is like the thing that I've been using for all of my Unicode testing. And this seems to be working out pretty well. It's got like basically pure Unicode code points, which is really awesome. It's like a great test because of that. But the point is that we need to make sure that this thing has approximately the same performance characteristics of the unordered map that is being used before. So we basically want a good way to measure what this unordered map is doing today. And that way we can kind of like project that and figure out like what the runtime statistics are of how we're going to modify this thing. I think let's get started on that thing first. And I actually added this a little while ago. So this just prints out some statistics about the map. And this could be actually useful. So if I go ahead and print this out like here, the reason we print it out here is because we basically want to hit a path when you're actually inserting an element, so we can tell like what the load is, what the element count is, how many buckets are null, all that good stuff. We can tell all of that information at the point when we're actually inserting elements. So if I do this and we go font glyphs map, something like that, that should work. Do I want to do arena tracking? No, I don't need to do arena tracking. So if we run this, right, and we go to tests, Unicode. Okay, so there's like a whole bunch of stuff that popped up on screen. Some of it's relevant. because this is telling us, so as you're scrolling down, it's like loading more code points. So we want to keep track of like, or we don't want to get an idea of the capacity here. So capacity is useful because it tells us how many total elements are in, or how many buckets are allocated for this thing. And then the next element is the count. That's like how many actual elements are inside of this, how many Unicode code points we've allocated so far. And then the load tells us how deep the furthest chain in that bucket is. And finally, the null slots tells us how many buckets are not being used yet. So this is pretty good, right? Like you can see the null slots going down pretty rapidly as we scroll down. The load still remains at about 3, which is good. We have 280, so it's like kind of we're using about half the capacity right now at this point. So we just went up to 4, right? We're using a little bit over half capacity. We're probably using about 2/3. So the key thing is like, when does it rehash? Let's keep going down. Our null slots are going down dramatically, which is good. You want that to go down very quickly. Okay, it rehashed right here. So we got 1024, so it doubles in size, or I guess it goes probably to the next power of 2. And then our load is actually the same, which is interesting. And our load slot, or our null slots are almost equal to the number of elements that we have. So we basically doubled the size, and we're only using half the size currently by the time we get to the end of the file. So the end of the file, they have, right, like 1024 elements in there, which is pretty good. This is going to be, and you'll see this when we start working on it, is that this thing is actually doing a lot more work than is necessary, because for code points, they're already sort of like a bijective function. Like a code point maps to a unique glyph, and a glyph maps back to like a unique code point, essentially. So it actually becomes a really nice invariant that we can use, to where we don't actually have to do any hashing at all. We can just take the code point and project it directly into our map somewhere. So you can like mod it with like the map size immediately. But what we're going to do is we're going to use and, because it's a little bit faster. Ever so slightly faster, but you know, we're going to exploit the pieces of data that we have available to us. So we need to go ahead and create some functions here that are going to allow us to do this kind of API. So we want to adhere to this. And this is important. So we have to have an API that tells us whether or not the element was inserted, and it needs to return a pointer to that allocated node. This is good for efficiency, because if the element's not inserted, then it gets or like if it reports that it was not inserted, then the existing element is returned. If it reports that it was inserted, then you get an iterator to that element that you just inserted. So this is kind of like the most optimal pattern that you always want to have for map-like data structures. In scenarios where you want to try and check to see if you need to insert something, just try to insert it. It's always faster to just try and insert it, and if you fail, then you know you can just use the existing element. That's the idea. You don't have to do a find, and then if the find fails, then try to insert, because you're doing double lookup at that point. Okay. I think that's enough explanation. So I think what we want to do is we probably want to use the same trick as last time, and essentially have this thing like if def'd out to do the same thing as last time. So, or like we're going to if def out this function and essentially replace it with a version that takes almost these same arguments. Right, we have the cache font, and we can stick the arena inside of there. Just like this. This way we don't actually have to change any of the callers here. There's only one caller, actually. So it's not too bad. Yeah, we should be good. But we want to keep this old code around so we can test it and validate that our assumptions are correct. So on map. So let's do like this thing here. If 0, or actually if old glyph map 0. We'll do that for now. So we have this, and if, or else actually. Old glyph map. I like having these little things that point out. Old glyph map. Not, or not. Okay, now we want to have some APIs that actually start inserting some stuff. So I'm just going to copy this thing wholesale because it's going to be essentially what we want. Except that we're going to have a pointer to a next node, like I mentioned. The next node in that bucket. We're probably going to end up stealing some code here. So spell check. We want to steal basically everything here, actually. Let's just steal all of this. And we're going to call this struct. We're going to call it the same thing, just to make it simple. Oh, dang it, I destroyed it. And instead of this, buckets. So I found that having these other fields here is actually really nice for debugging purposes. So if you have like a capacity, an account, and your nil buckets and all that fun stuff, that's actually super nice. Okay, we're gonna reuse this thing because these have been very helpful functions. So where do we want to put these? There's a good place to put these. Maybe not constants. Probably not types. We might want to actually invent a new header here. Let's invent a new header. I'm going to just reuse this as I do this occasionally. We're going to call this bits.h. Is that going to... bits. Just to make it simpler. And so we don't actually like... Yeah. And so we don't collide with like system headers. But we're going to put these things in there. So these two are going to go in here, I think. That's the idea. Oh, what did I just break? Oh no, what did I just break? That's not good. That is interesting. I'm not sure why we're crashing here. Let's see what Task Manager says. This is the good thing about dogfooding your projects. Ah, okay. So we're basically gonna explode our allocation here for some reason. I think I have to kill this. Oh wait, no, now it's going down. No, we're going back up. I am really not sure what's happening there. That's just crazy amount of memory. Yeah, that's just gonna eat my memory. Okay, I think I might have to kill that. Yeah, that's just gonna have to die. Okay, well that's fun. That's a fun little crash that I'm gonna have to figure out later. Rel. So source, we're gonna go to glyph cache. We're in old map here, and then we were modifying our include header, right? Bits. And spell. How to up how to. Oh no, did I already delete it? Criminy. Okay, let's save this time. Well, I can get it from the Git history. Let's just take this. Oops. I'm gonna dedent you. Okay, so all this is doing is it's just taking this, whatever the input is, and finding the next power of 2, or finding a power of 2 that is big enough to hold it. This is good for creating table sizes that are powers of 2. And then this is just asking the question, hey, are you a power of 2? Which is just a useful thing. But we want to include types.h here, since we need uint64. And that should be the only thing we need for these two functions. We're probably going to add some more functionality here, which is why I created bits. Like, I could see me needing stuff like, hey, extract the bit pattern, or count the number of bits in this position and all that fun stuff. So we'll probably put some more stuff in there over time. But for right now, we need to include Fred bits.h. Put it up there because I like having them be in sorted order. Okay. Glyph cache. Okay, let's open our... Actually, I don't know why I closed spell check, because we're going to need it still. So for this, we want a function that's going to create this Unicode map, make glyph map, make Unicode. I'm going to say Unicode because it's possible I might want to use glyph map for something else, since it's a little bit more generic. And then unit 64T. Okay. So we're gonna do all the same stuff basically. So a lot of this it just turns into copy paste, which is like sometimes a no-no, but I think in this case we're probably fine. So here we want to change all of these to be map. Yeah. Capacity, buckets, and then this is going to be Unicode glyph info. Cool. And now we want to have something very similar to this. So I'm going to steal this again. Push. Is it? Why is Unicode not in the dictionary? That should be a thing that's in the dictionary. This we're gonna take in the, oops. I really have to change that behavior. I changed the behavior a little while back to be like, whenever you start testing and you hit escape, it just gets rid of the suggestions. But if you're in Vim mode, when you hit escape, it should kind of try and prefer setting you back to command mode instead of keeping you in insert mode, even if another widget is there. That just actually, it just catches me off guard so much that I have actually, I'm regretting that change so much. In fact, that's like so annoying, I might just fix it right now. It's the great thing about being able to dog food your stuff. So what did I end up changing to make this work? So suggestions. So here's where we actually build the suggestions input. Yeah, so it's in the suggestions thing. So if I go to suggest CPP escape, so whenever escape is hit, we eat the input so nothing else tries to process it. I think that's the thing that actually needs to change. Yeah, let's just, we want to set the context widget to 0, but we don't want to change the, we don't want to eat the, we don't want to eat the input. Yeah. Yeah, and the UI actually added this function. Eat, right? It eats a specific key. Just sets it to nil. Okay, yeah. So let's actually recompile real quick. I'll just set it. This is the nice thing about keeping the old code around. We can just set that and then build our project. Fred. Nope. No build. Oh, right. Wrong directory. Okay. So let's actually try to build Fred. So if I try to type something like F, and I go escape, nice, it works. Let's use it. Okay. I'm gonna just dog food that right away. Big C. Cool. So here we are at our glyph cache. I also want to add, like, whenever you reopen Fred, it's gonna remember like where your cursor and stuff was. Because that's a thing that bothers me. There's actually a feature ask on the Discord for that. There has been for a while, and I will get to it. I will get to it as soon as this whole nonsense is sorted through. The arena's nonsense, that is. Okay. Spell check. Okay. We're stealing code from this, so that's why I'm keeping that as like a reference. Map. So you are the map here. Ah, it feels so much better, actually. That one change just feels infinitely better. Okay. So here's the thing. We're actually not going to need to hash anything whatsoever here. And I mentioned this a while ago. So we can take out the hash piece of it. And what we're going to get in here... So if I look at... Let's actually pull this over here. If I look at what we need to insert... So here's what we in place. We try to put a glyph there, and we have rasterize potentially. But let's pretty much just try and put the glyph there and allocate some the Unicode code point info at that glyph point. So all we're going to need here is a glyph. So code point glyph, right? That's nice. And this thing probably should return a struct. It should return this glyph info thing that's either the existing entry or it's going to return, or it's going to return like the new entry that we just inserted into the map. Maybe we should call this try push because of that. Try push. So we're gonna have a structure here first. So this is going to be a result, and it's going to be this Unicode code point, oops, info thing. So the node, and then we're going to have bool inserted. Yeah, I think that's reasonable. Let's just take this thing here. Cool. So we're going to get this result guy. So and here's what I mean. Like, we could take the glyph and just do this. Because it's already a unique code point. Like, we don't have to hash it. Hashing it would just be a waste of time, actually. Okay, instead of set, this is going to be map. Map. So if slot's null putter, we know for a fact that we're going to insert. So actually, result true. And let's do it at the end. Okay, otherwise set. We're going to change all of you. The map, right? So we increase the count, decrease null buckets. The load we're going to change. And the slot is going to be this thing. Slot. Do we need to insert anything into the slot? I don't think so. I think we can actually just set all this stuff down to 0. Because the caller is actually going to handle filling out this data structure. So I think not doing anything here is fine. But we do need to assign it, which is what we're doing here. Do we want to keep... So here's the thing. We could do slot down here. And we could assign slot at the end. Do we want to do that? Yeah, we could do that. This way we do something like results dot node equal to slot, something like that. We could even assert that something like that might be useful. I think I have seen assert in here, didn't I? I do not. Cool. So this was strings before, but that's not what we're going to use here. We're going to say slot. Oh, we do need the actual Unicode thing here. Right. We've never needed the we'd never needed the code point here before. We basically can't just discard the code point is what I'm saying. It has to live in this structure. So before over here we were like the edit became the key in the spell check case, but here we need keys separately. There's always this question I have where like, do I want to allocate the key in this code point info or do I want to allocate the key separately? And I think the answer is always correct that you want to separately allocate the keys. And the reason for that is because you basically want when you load like the key structure, you're basically like looking at keys first and then you're loading the data. So having this next be here is probably incorrect. What we actually want is we want a key data structure, and the key data structure has a next. And the key data structure has a pointer to this thing that's allocated separately from it. Because you don't actually need to load this until you know that you have the right key. So I think that's probably the way to go. So struct code glyph key, something like this. Let's have this be up here. Okay. So we don't need you to have a next. We do need the key to have a next, though. Oops. Dang it. Next. And then UTF-8 key. This way we can have this. If this is separately allocated like this, info, something like that. when we load this data structure, it's just like 3 pointers, which is much cheaper to load than like loading this thing, which is a whole bunch of floats, and then this thing, which is I think just a pointer, and then like basically another align pointer here. So we're looking at we can even count probably. There's a pointer width here in 64. So that's 2 pointers there. 2 and then 3 and 4 pointers as opposed to 3 pointers to get to the key. Yeah, I think I like that a little bit better. I think I like that a little bit better. And since we don't need to remove from this map, we should be fine to just store it like this. Now, if I wanted to reuse nodes and stuff, then I'd have to have a free list for this thing and then like a free list for the other thing, and then it gets a little bit more complicated. But because we're storing it like this, it should be fine. Now, the other option we could take is take this out and then have like 2 sets of buckets. Nah, that just sounds like way too much extra memory for not a whole lot of gain, in my opinion. I think having just the 2 pointers is fine above the key. Right, so now we're allocating this thing. It's going to be this instead. Where are we using? Unicode glyph info. So we're pushing an array of actually key slot. And then we're pushing a node data structure. Yeah, the result needs the node. It doesn't need the actual. And we're storing it already in results, so we're going to have that. Or actually, let's do it in slot first and then store it in results. So I think we're probably going to end up doing it like slot slot node or slot info. Actually, let's call it data just to be more consistent, or like basically a little bit more generic with our naming here. Okay. And then slot data. Info. We know we're going to need both of these things in this new slot. Cool. Okay, so here, this is the thing that's going to get a little bit more interesting. So the slot E is equal to glyph. So if this is equal to glyph, we're not going to insert. We're going to break. Or if so slot key is equal to glyph again. There's an extra parenthesis here. So this kind of is like a fall through whenever we have. I mean, comparing this twice is fine. Like if we come to here, then we'll just compare it again and we'll say, hey, insert's not. I mean, I could test for not insert, but it's like not that big of a deal. This thing is to fall through for whenever we have no next pointers. So like if this happens to be the only bucket or the only chain, like the head of the chain, then this will fail and we'll go to this test and test against the head of the chain. Otherwise, we're going to insert, so we need these two things. So we need the entry is this thing. New entry data is equal to this thing. Right. So then slot next is equal to the new entry. And then slot is equal to new entry, because this is the one that we just inserted. Yeah, +2 for the new node. Cool. That should be good. Let's see how bad this will compile. I'm not in the right directory. Do we have any errors in our new code? UT8 136. UTF8. Pow up. Oh, I need Fred bits. Okay. So we need, oh, edit node is still there. 169. Of course. This is going to be replaced with the key node. Yeah, slots. Set, I called it set still. Set, okay. This is map. Okay, there should be significantly fewer now. Oh, oh my gosh. I called it set somewhere else. 206. I sure did. Okay. Okay, cool. Anywhere where we're using this old thing, we need to change, basically. So cached font is going to have an arena. Maybe I should just call this arena. I'll be specific. You don't pay per name, so or I guess it's just in typing is where you pay for it. But I'm not offended by it, so it's fine. So this is going to be if old glyph map. All of this stuff is going to be done. Else. You're just going to copy this basically. We don't have map stats yet, but we will. We will. So, try push. Okay. I think by the time we get to this point, I want to assume that the map is already created, so we can start playing with it at this point. So, auto. I can use destructuring again. So we can try push Unicode glyph, and then font map arena, and then I'm going to pass it the map. And then we pass it the code point, the glyph, and then that's all we need. So if the node is not rasterized, let's find all these instances of iter and replace them. There's only a couple, which is nice. Info failed to rasterized. Actually, let's call this info, right? This way we can just use this. Yeah, we can just use this directly. Info, info, info. Info, we can just return you directly. So otherwise, we have info. Dang, I think, like, for the most part, that's basically all we need. How far are we from compiling? Clear. Okay, yeah, cleared is definitely not a thing that exists. Yeah, the great thing about this is that clearing, since none of these are managed by the actual, like, these are all just C objects, right? Like, this is just a handle that's separately managed, all that fun stuff. We have the opportunity to just clear the map. Or clear the arena and then immediately jump to where we need to be. 51. Yeah, here. If old glyph map. Okay, so we can just do something like arena clear. Glyph map arena, clear that guy, and then we can do data make glyph map. Font glyph map arena, and then let's start with a table that's like, I don't know, like 4K, I guess. Let's do 1K. That's all we need. Cool. Oh, now we can't. Glyph cache font. Selected. Oh. Selected font. There we go. Or set at the old capacity again. That's actually not a bad idea. Yeah, you kind of just keep the arena consistent, don't you? Ah, I forget you can just do that. That's so much smarter. Hey, how you doing, Ratchet? Good to have you saving the day once again. Selected font. Capacity. Yeah, that's a much smarter idea. Let's break up this line because this is getting a little out of control, I think. Yeah, it's much better. This way I can sort of figure out up front, or figure out in one place what that size should be, which I still don't know. So if it's not inserted. Okay. Wait, this is only if, so cached fonts. Okay, so cache fonts clear is going to need to do something other than clear. Okay, so actually this is the place where we are going to need to figure out what that size is. However, in the old spot down here, this we're actually going to need to nuke the arenas. Yeah. I'll just call it cat. This is gonna go away eventually, this for each loop, but it's fine how it is. And here we're going to arena. Do I need to do anything else? No. Glyph map arena. And up here is where we're going to need to allocate it here. Arena clear. So this is going to be something different instead. This is going to be... So what do we want this capacity to be? Let's start out with a 1K table like we were going to do before. I think that seems reasonable. Default params. Oh, if I could spell it correctly. Yeah. Not a member of cache font. Oh. This thing. Oh, this is because this is a map itself. Oh, gosh. What is the pair again? It's a code point and then the cache font. Right. Right. Hey, how's it going, Piggy Bank? Good to see y'all here. I know it's a little bit of a late stream, so yeah, thanks for stopping by. Appreciate it. We're just doing some more hash table building. Trying to figure out what the correct load balance is and all that fun stuff for our hash tables. Let's see, build Fred. Right now we're replacing the hash table that's in charge of managing code points to Unicode glyphs themselves. So I just replaced it. We're about to see if Fred's gonna crash. It definitely did not request the glyphs correctly. It's not even getting the measurements correctly. I'm not sure what's going on here. And our performance is gradually degrading, so I'm not sure what happened there. We obviously did something wrong. So let's figure out what we did wrong. So let's do push. I doubt it's actually the problem is in here. I somewhat doubt the problem's in here. It's probably something to do with how I'm using a profiler. Yeah, so I use Tracy to figure out like if so I keep the old algorithm around and then I use and then I implement the new algorithm and then I take trace profiles of both of those things and figure out like where the bottlenecks are. In addition to that, I have a whole bunch of like UI elements that I just add, ad hoc that tell me different informations like load balancing measurements and stuff like that, like the quality of the hash that I'm using, all that fun stuff. Yeah. Tracy is like super nice. I just have this Fred core. So, or actually it's in macros, I forgot. So in macros, I have this thing here. So whenever I build profiled, I have these like macros that expand out to different Tracy things. And then I have all this extra junk that does more Tracy things. But you'll see these occasionally in pieces of the code where like I'm just benchmarking it and trying to figure out like, oh, did I do something dumb here or not? It's been extremely useful. And then I have a build configuration that does that. So if I do like build that profiled, yeah. So in profiled mode, it adds the macro and then it includes like the Tracy junk and then off you go. That's all you need. Why did I just make the fonts a little bit smaller? There we go. So now we're trying to figure out what I did poorly here. This should be a pointer. Something did not get propagated correctly here. So the hash table is being used for glyph lookup. Yeah, so this way I don't have to have like this hash table is like code point. Right now it's code point to specific Unicode glyph. Eventually, and I mentioned this at the beginning of the stream, this is going to need to change to something that's similar to like a for when I support grapheme clusters or stuff like ligatures, you're going to have multiple code points here. So this is going to be like kind of a mini array or something like that. The point is like it just hashes to something, and that's all you care about. So when you get that, when you have that result, that's what becomes your key. But right now I could just rely on the fact that it is like a code point is it's an injective function to a specific glyph information. So I don't actually have to hash it at all. So I can take the glyph itself and use that as if it were a hash and get the index that I need to add to my table. And it turns out that works out pretty well because you'll find that like when you're traversing a whole bunch of glyphs, they tend to give you like really good distribution if you do it that way. Because they're usually like back to back to back to back, so you're just like going down the line and adding certain glyphs to your table. Now that could be challenged, so like maybe that assumption is a really poor assumption, but I think for now it's a pretty okay one. We'll see. Time will tell. But I need to fix whatever in the heck this bug is first. I don't know what's going on here. So we have our arena allocation for this data. I wonder if... I'm trying to think of an edge case where that isn't true. Yeah, I mean, it very much could be true. And like the main test I have for this is like this file. Oh crap, there's like a whole bunch of profiling stuff. But anyway, I have this like one file that has a whole bunch of Unicode stuff in it, and this has been like amazing for testing out my Unicode support. And then there's like various other files of the repo that have Unicode characters in them. And that's been extremely useful for figuring out like, is the implementation laying these things out correct? Is it like fetching the right font for these things and all that fun stuff? And is it keeping alignment of like, you know, glyphs that need specific alignment correct? Like if you open this up in VS Code, it's super jank. And that's because VS Code is really bad at stress, right? Like some of them it doesn't even load properly, and like it does weird stuff with some of these, and like it just doesn't get any of these right at all. But you could see like the difference. Like here's Fred, right? Here's what it looks like in Fred, and here's what that same table looks like in VS Code. It looks like a little too cramped, and it's not quite modulating some of these characters correctly, like this. Anyway, so that's kind of like a difference when you end up doing it correctly. Okay. Let's figure out what we did wrong here. I really don't want to have to debug this thing, but let's see. Oops. Okay, so whenever we have this result, we're assuming not inserted. Okay, I think here's where the bug is. Result true. Okay, so I think what was happening before was we were believing it was not inserted, so we went through and we rasterized the glyph in that same spot, and we just kept filling out our table. That's exactly what was happening. It's made with web technology. Exactly, right? Yeah, VS Code. It's how could it be imperfect? I mean, it has AI built into it. It's got to be the smartest editor on earth. That's exactly what was going wrong, though. It wasn't. We were trying to request that glyph slot, and we hashed to the right slot, and we claimed it was not inserted when it was already in the table, and that was blowing up everything. So, but funny things happen when you break your invariants. Oh, it's still broken, huh? Yeah, see, the fact that this was getting spammed with output here tells me that we were not getting the glyph. That we were not fetching the glyph when we should have. So... yeah, I can increase the font size. How's that? Is that a little better? I can make it bigger too. Yeah, I'm still kind of getting used to streaming, so I definitely let me know if I can speak up or if like my voice is unclear or something like that, or if I need to explain something that I haven't explained. And things like font size, like that's a good one to call out. Okay. So we said result was inserted, which is correct. Otherwise, we're not going to insert it. And we're going to keep this slot locked onto whatever glyph it was, which is correct. I am a terrible pirate, I will say that. I will say that up front. I cannot fulfill that request. I'm sorry. Maybe if I start up a Patreon or something, I can start studying Pirate if enough people request it. Maybe that'll be like a tier. Get access to the pirate stream if you know, donate X amount of dollars. No, I won't make people donate for that. If I could talk pirate, I would do it all the time. What are we doing wrong here? Oh my gosh. I did this mistake last time where I forgot to set the freaking key for the slot. So slot key glyph, right? Jesus. New, yeah. Key is equal to glyph. That's exactly what we were missing. Tried Fred on Linux. It works surprisingly well for a beta version. Thank you. I appreciate it. That is it's the Linux version, I mean, it's a labor of love. Um and I really do dearly love Linux, and I used it for a long time until I had to forcefully move to Windows for my job. So I definitely want to put a lot of good effort into making the Linux version good. There's a lot of steps I need to take to make it a lot better, though. It's missing a whole bunch of stuff, and I think I want to move the UI layer to be Wayland based instead of X based, because I know X is kind of like there's this big rift in the Linux community where it's like, you go Wayland or do you go X? And maybe the answer is like just support both and query which one is active and use that one. Yeah. What did I do? Oh, okay, we need to rebuild. Yeah, I hope you're laughing at the fact that I completely just botched that key insertion. Yeah, that's pretty amazing. Let's see if it's broken. Hey, look at that. We're able to get glyphs. It looks a little weird. I think I'm not getting the size of those correct. Yeah, it looks weird. If I size it down, does it look correct? Oh yeah, it looks correct there. Okay. Let me make a note of that. Let me make a note of that. Uh, what's the font size there? 16. Okay. Okay, so we have a working implementation. So now comes the question of like, how good is it? How good is this implementation versus the old implementation? Oh, let's actually test one more thing here. Oh, oops. We want to test to make sure that we can size up and size down the font correctly. Ah, see, we have a crash. We have a crash, and that's not good. So what did we do? I think we might have to let's see if we can repro it first. So if I size down, size up, size down, up, down. So why was that broken? What? Huh. I don't know what happened there. I don't know how we ended up crashing. It's really weird. Let's build with ASAN. Let's build with ASAN before we try and debug into this. I don't think we actually... I don't have anything to debug yet. It's like... I don't know what's going on. ASAN, like, explodes your memory usage, so this might actually fail to load. Oh, yeah, something exploded. Oh, yeah, we're accessing a poison memory. Use after poison. That's fun. This is why you always want to have an ASAN buildable version of your application. Identify font face for glyph. And so this is where we got our poison data from. What was it at? Or 310? 310, 310. This is poison, huh? Or like this pointer is poisoned. That's weird. This arena, you have a scratch. That's really quite surprising. Is only caught with ASAN. Yeah, I mean, sometimes you catch that in, like, usually it just manifests as weird stuff whenever you're using arena memory that you've quote unquote deallocated, right? You pop back, but it's like you're still using it somewhere. If you manage to poison your arenas, your arena deallocations, it's like such a useful tool for finding these kind of weird bugs. I might actually have to jump into VS Code for this one, because unfortunately, like, a rad debugger doesn't quite have, like, it has some ASAN support, but being able to find those like uses after poison is extremely difficult. Tests, Unicode stress. Okay, where are we at? Okay, here we go. So this is a bad memory address somehow. How is this a bad memory address? Data info. Is it because... Oh my gosh, I cleared these arenas. Oh, but they're cleared though. Like, it shouldn't have any references to these things. Like, these are gone. So it shouldn't have any references here. That's bizarre. Because I'm pretty sure that this is what happened. Like, we got to this release, and then bad things happened. So, or maybe not. No, we probably didn't get to that release. We shouldn't have. Yeah, we never got there. So this is not a breakpoint that's actually hit. So we're trying to pull it. So it is inserted. Here we can actually see like what our what our table looks like so far, though. It's kind of cool. $10.24. Let's actually put this thing in our debugger. And 10.24. Sheesh. Okay, yeah. This is very sparsely populated, but you can kind of see the entries here. $28. No, I don't think that's actually going to help. Use after poison. Why does it think this thing is poisoned? We never clear it. Is this because... I kind of wonder if there was a arena that was allocated here. And this scratch arena, so the way that this could potentially happen is that somewhere along this API chain in files.dir, we allocated another scratch arena that did not take this enclosing scratch arena into account. Aha, there it is. Look at that. Look, just like we predicted, right? Just like we predicted. Yeah, yep. That is exactly our bug. So let's fix that. Weirdly, I never hit this in my other cases. So so that's in files in dir. Yeah. It needs to take that into account. Yeah, exactly. Arena aliasing. They're just so like nefarious. They're so like they're so subtle, and stuff like ASAN is so good at catching it. Like that's why I love having ASAN around. It's such an amazing tool. Let's get back to our tests. Okay, so ASAN seems to be happy with this. God, that looks so weird. I don't know. Let's make sure. Yeah, we're able to rasterize him again. I don't know what that crash was all about. That was super weird. Yeah, I think things are looking fine. I don't know what that crash was all about. That's just weird. That's looking good, though. Cool. Yeah, so now we can start adding some statistics about our glyph cache. So we have this thing that prints some statistics about the old map. Let's actually just copy this and kind of put it closer to where we insert over here. So let's put that here. Actually already have all of this information. We have the null slots. We have all this information, actually. But we do need the feed for all of this reasons. Let's put you down here. So let's go up to our map and see what our fields are one more time. Okay. So we need capacity, count, load, and null slots. So we have capacity, count, max bucket, load, map, load, and then so we can actually print this out at the same time that we're doing this. I call it. We can just build. We don't need ASAN anymore. So we have a load of 1. Now remember, when we were going through this with our old map, by the time we got to the bottom with the standard map implementation, we had a load of 4 and a count of 1,024. So right now we already have 1,024. So let's see if our load goes up like significantly by the time we get to the bottom. This is actually good. So our load stayed at 3. So it's got an even better distribution by not hashing the Unicode glyphs. So it's already just a better hash table up front. That's very promising. So I think I might call that hash table, at least like that specific hash table, I would call that done for now. So in super Unicode heavy files, like let's say everything's a Unicode code point, it might get a little bit slower since I don't have rehashing implemented. But I think this is perfectly acceptable for now. Like that file is such a good test case to figure out like what we're doing wrong, right? You can see our diffs. I really need a key to go back all the way home. That would be nice. Instead of scrolling forever. These are all the edits that we've made to this file. So it's kind of acting like git diff for us right now, right? Like all the red is showing what we would delete if we got rid of all the edits right now. Yeah, it's looking good. Okay, here's our push function. We started with that edit node. Yeah, it's looking good. Cool. Yeah, I think I might call the stream there. I know it was a little bit shorter. I wanted to get a quick implementation of another map data structure done and kind of at least go through the proving process of, is our implementation good enough? And I feel like that's a pretty good example of like taking a thing and moving it into arenas and doing the necessary analysis to make sure that it works well enough for your use cases. We might do some more work, like a second pass on some of our hash tables later on, but I want to do that after we move everything over to arenas. This way I have a much better, like, I don't know, experience with just arenaizing everything. So I know how everything works end to end. Anyway, yeah, thank you all for stopping by. I appreciate all of you, and have a great rest of your night or morning, as the case may be. All right, thanks.